Welcome to the closing plenary of the first IAEE Online International Conference. We have a very distinguished panel for this closing session, and it consists of people from all around the world, including myself. My name is Yukari Yamashita of the Institute of Energy Economics Japan. I served you as the president of the IAEE last year, and now you're executive vice president. To the panelists from around the world, I have asked one question: what new energy landscape you see in your country or region, and ask them to make opening remarks answering to the question, including challenges, solutions, and potential tips for future research. I hope you will enjoy the world trip with us for the coming 2 hours. So first panelist is Professor Frank Wolak of Stanford University, USA. Frank is Director of Program on Energy and Sustainable Development and a professor of the Department of Economics. Floor is yours, Frank, please.
Hello, my name is Frank Wolak, and I'm going to speak about the new energy landscape in the United States, which is wholesale electricity markets with significant intermittent renewables. There's been explosive growth in the megawatts of intermittent renewable capacity in the US over the past 10 years. California and Texas have led this effort, as you can see from the graph. Each state also has formal wholesale electricity market with a finite offer cap. California has almost 20,000 megawatts of wind and solar capacity, and roughly 22% of the energy consumed in 2020 came from wind and solar. Texas has almost 27,000 megawatts of wind and solar in 2020, and 24% of the energy consumed there in 2020 came from wind and solar. There's also been a significant amount of capacity retirements, roughly almost 12,000 megawatts of thermal capacity retired in California between 2013 and 2020, and almost 5,000 retired between 2010 and 2020 in Texas. This new energy landscape has created some challenges. In particular, California has experienced a supply shortfall during the evenings of August 14th and 15th, 2020, that required rolling blackouts. And during this time, there was significantly lower wind and solar output than firm capacity of these resources. Texas experienced a supply shortfall during the February 2018, 15 to 18 of 2021 that required rolling blackouts as well. And this was the result of significantly lower solar and wind output, as well as reduced nuclear plant output, the failure of the natural gas delivery network, and certainly a higher electricity demand due to the extreme weather and large increase in electric space heating in Texas. So what is the challenge of this new energy landscape? Well, it is ensuring a reliable supply of electricity in a wholesale market regime. So how did we do this before we had wholesale electricity markets? Well, in the vertically integrated regime, we had a monopoly supplier that was the sole entity responsible for ensuring system demand was met. In the wholesale market regime, there's no single entity that's responsible for that. The ISO can only operate the market with the research offered into the market. Generation units can only supply from the units they control. Retailers can only purchase the energy that generation unit owners supply. And so unless the regulator treats electricity like any other product, and we'll describe what that means in the next slide, the wholesale market regime is going to require a long-term resource adequacy mechanism. And this is necessary because what I like to call the reliability externality. And that is, if the regulator is unwilling to commit to using the real-time price of energy to clear the market under all possible future system demand conditions, what we have is a reliability externality, because all consumers know that when supply is insufficient to meet demand at or below this offer cap, there will be not specific customers blacked out, but there will just be simply random blackouts. So this means that no customer faces the full expected cost of failing to procure an adequate amount of energy in the forward market. And so this creates an incentive for consumers and retailers to over-rely on the short-term market. And so because of this reliability externality in markets with a finite offer cap, we need to have a long-term resource adequacy mechanism. So what is the historical approach that's been used to ensure this reliable supply of electricity? Well, historically, it's been capacity-based long-term resource adequacy because of the initial conditions listed here, which is I have an electricity supply industry with thermal generation resources, mechanical meters, as well as this offer cap on the short-term market. And I'm worried about whether I can meet the system demand peak with the capacity that I have. So how does that work? Well, retailers will be assigned a firm capacity obligations equal to a multiple of their annual peak demand, say between 110 and 120%. And for thermal units, this is quite easy. You simply take the installed capacity of the unit, multiply it by the availability factor of the unit, which is the fraction hours, years the unit's available, and that gives you the firm capacity of that generation unit. So let's take a simple example. We have a peak demand of 1,000 and a market composed of equal size units with an availability factor of 0.9. And the important point here is the fact that these generation outages are independent events. And so if each unit has 100 megawatts of capacity, then the firm capacity of the unit is 90. And if we have a firm capacity requirement of 1.17 times peak demand, that means we would have 13 units. And using the binomial distribution, we can compute that you'd meet the demand peak with 0.96 probability. However, the market of that size with 13 units is pretty small. Most markets have many more units. California has more than 1,000 units. So let's take a more realistic example of the units are 20 megawatts in size with the same availability factors, and each unit has 18 megawatts of firm capacity. In this case, a firm capacity requirement of 1.17 times the peak demand ensures that we meet system peak with 0.999 probability in a market now composed of 65 generation units. So what this says is for a thermal generation system, this mechanism, a capacity-based mechanism, can be designed to ensure that the peak demand is met with an extremely high probability. But this relies heavily on the independent of forced outages of the 65 generation units, which is a reasonable assumption for thermal generation units, which we think is the reason they're not available is mechanical failures. But it's a very unreasonable assumption for intermittent renewable generation units. So for example, in hydro-dominated systems, the El Nino, La Nina events make the availability of water behind dams extremely positively correlated across locations. Similarly, the hourly availability of energy from wind and solar units is extremely positively correlated. Just to give you an example from a paper of mine, the following diagram you can see is that, think of the straight lines that I'm drawing are saying that this is essentially, as you add units, this is how much variability you're picking up as you add generation units if the units were uncorrelated in terms of their hourly availability. So let's take the 13 solar units that exist. This would be how they would go in terms of the percent of total variation in the hourly output of the units. But what you can see is, in fact, with most of the variation is explained only by one, if you like, orthogonal factor. And all the others explain just very little. For wind, you can see the dotted line here would be the case as we have total variation explained. And this is what's actually true for the 40 wind units in California. So the closer that you're getting to this upper corner, the more highly correlated all the outputs are. And as you can see, for both the solars alone, the winds alone, and then this line here, the solar and wind combined, there is a tremendous amount of contemporaneous correlation in the hourly output. So this creates significant problems for a capacity-based long-term resource adequacy mechanism because of this large contemporaneous correlation. This it doesn't even address the issue of the fact that when do these stressed system conditions occur versus when do essentially intermittent renewables produce output. So for example, if the stress system conditions occur when it's dark, as it did in California in August 2020, then the firm capacity of the solar is pretty close to zero. Similarly, if it occurs when the wind's not blowing, the firm capacity of a wind unit should be zero. And here's sort of a simple model to illustrate. Rather than go through the math, I'll simply take you to the conclusion, which is what we get in this case is, because of this correlation, we get that the marginal contribution of each unit of capacity to this probability that I'm going to be able to meet the system demand peak depends upon both where the capacity is located, how much is located at each location, as well as the correlation structure of availabilities, which makes it an extremely complicated problem to even think and contemplate of computing the firm capacity, and implies that there should be a firm capacity value that differs by location or even the same technology. So California attempts to do just this in terms of computing what it calls the effective load carrying capacity, and it attempts to account for this correlation. But as what we find is during this period of August 14th, 15th of 2020, both of the amount of output from solar and the amount of output from wind was significantly below the installed capacity or firm capacity number for solar, as well as the firm capacity number for wind. And in the case of Texas, during the period February 14th to 18th, the capacity factor of wind and solar in California, in Texas, was significantly less than the average for the remainder even of the month of February 2021. So the conclusion we draw, and this is discussed in the paper cited here, is that the firm capacity approach is certainly poorly suited to regions with high shares of intermittent renewable energy. So what is a possible solution? Well, a possible solution is to emphasize that this energy-only market versus capacity market dichotomy that's often discussed is a false dichotomy. As we discussed earlier, the long-term resource adequacy mechanisms necessary in any energy market with the finite offer cap because of this reliability externality. And the interesting thing is, even in a market with an extremely high offer cap, such as Texas, it is required. And it just, the only thing that a higher offer cap does is reduces the probability that you will get this supply shortfall, but it doesn't obviously eliminate the fact that this reliability externality can occur. All right, so the approach that I think suggests is something working off of a standardized energy contract approach. This is described in the two papers described below. And just to conclude, we want to say that this combination of a wholesale market with the finite offer cap creates this reliability externality, which requires this long-term resource adequacy mechanism to internalize, and that this traditional capacity-based approach is unsuited for the reasons that we've just discussed. And in terms of how can IAEE members, they can work to help design mechanisms that's focused on ensuring a supply equals demand under all possible future system conditions and renewable output levels. I would advocate focusing on financial incentives and financial products that will help to attain the least cost supply of resources, dispatchable generation units, batteries, demand response to ensure a reliable supply of electricity. So thank you very much.
Thank you, Frank. Your talk is related to the very hot topic of this winter. Similar situation took place in Japan, actually. It was colder than forecasted and electricity demand went up. But cold, snowy winter was no good for the solar panels, and additional LNG was not easily available very quickly because of several issues at the supply side. Therefore, many people tried to understand the Texas case with keen interest in Japan and so are the others in the world. So, and also I would like to thank you for giving a tip for future research theme for the fellow IAEA members. So now the question for you is that California and Texas stand out as advanced examples with wholesale market regime with higher share of variable renewable electricity. So let me ask you, Frank, what kind of lesson the rest of the USA or the world can learn in designing their energy policies or electricity market?
Well, thank you for the question. I guess as I mentioned in the presentation, I think that these capacity-based long-term resource adequacy mechanisms certainly start to make a lot less sense. So that would be my big lesson from the experience of California and Texas. I think it's no surprise that these are the markets with the by far largest share of intermittent renewables in the United States, and they experience these issues. Whereas the markets in the eastern United States have significantly less intermittent renewables. So to the extent that they attempt to scale the amount of intermittent renewables, I think similar issues will arise there. So that would be the big lesson, is just that hopefully the simple example that I illustrated of the massive increase in complexity and information necessary for making a long-term resource adequacy determination in an intermittent renewables dominated market is really a significant outstanding challenge that needs to be, I think, addressed through incentives, financial instruments, and other sorts of things that will, make the reality that we meet demand all hours of the day occur.
Yeah, so certainly this topic or this theme is very relevant to almost all the rest of the world, because we are trying to introduce this intermittent electricity in the bulk. Even though if that part of the world is not yet done so, sooner or later they may face the similar issue. So it is certainly the area to look into as researchers in the energy economics. So thank you very much for pointing out, and you have given us a lot of information where we can start looking into this issue by first start reading your papers also. Another question I would like to ask you is about President Biden's firm determination to commit to the net zero by 2050. Can you give us a quick summary of how the US government plans to meet this challenge? I imagine that it is not limited to variable renewable electricity. Is nuclear part of the picture? How about hydrogen or ammonia or any negative emission technologies?
Yes, I guess what the way I would answer that question is to say to be determined, but certainly the Biden administration is very much a big supporter of renewables, intermittent renewables, wind, solar. One of the big things they're pushing for, whether or not it happens, is offshore wind. We'll see how many of those get built, since they typically are located places where people have vacation homes, and they may not like that. But one of the other is they haven't said no to nuclear, but they also haven't said yes to nuclear. My favorite one is we have this guy in the United States called Bill Nye, the science guy, and his big thing he's pushing is nuclear fusion. So I would expect that it's going to be, that this will start to become sorted out. But given the ambitiousness of the Biden administration's goals, it strikes me as an all of the above strategy, even involving carbon capture and sequestration, is worth consideration. So otherwise, I think it's going to be very difficult to achieve those. But they're still in the formulation stage as far as beyond what I just said.
I see. Thank you very much. But the world is looking at where the United States is going, because we ourselves do not know how to actually meet this target. And somebody, actually it was Hoson Lee today, mentioned that all these empty promises, but we have to go towards that target. Therefore, I hope that there will be more, how to say, clearer pictures we can share in the near future from the United States as well. So, well, thank you very much, Frank. I will come back to you later again. Okay, so now I would like to invite Mr. Adam Sieminski, President of KAPSARC, Saudi Arabia. So Adam is going to give you the presentation live. So Adam, floor is yours.
Thank you very much, Yukari. I thought first I would try to describe or define what I see as the new landscape. And I think it's really the tremendous energy transition that we have underway. And there are different ways of thinking about that energy transition. One way that you often see is the global energy sector is shifting from hydrocarbon-based or fossil fuel systems for both production and consumption to renewable energy sources that Frank just described, wind, solar with batteries and so on. What Frank said is there are challenges on the electricity side in doing this. And there are also challenges and opportunities on, I think, the oil side to think about the transition in a slightly different way, one that focuses on emissions like carbon dioxide, but thinks of it more as a shift to cleaner fuels and carbon managed fuels that can remain accessible and affordable. If we could go to the next slide. Everybody agrees that climate change is a very key area for focus globally. We're concerned about rising temperatures, which have gone up considerably since mid-century. The scientific community has declared that we have to take aggressive action. And global leaders, first at Paris, but in a continuing series of pledges, have said that they will try very hard to limit temperature rise to below 2 degrees Celsius and maybe 1.5 degrees. So let's look at the next slide. The challenge that I see, Yukari, in this is that some people are saying, well, let's ban hydrocarbons because this is where a lot of the emissions are coming from. And I see that as being a very narrow focus that could lead to highly, highly undesirable economic consequences and certainly geopolitical and economic consequences in the Middle East, North Africa region. Some of the issues that come from a almost exclusive focus on banning fossil fuels, or what are you going to do about the very hard to abate sectors like aviation and ocean transportation, industries like cement that require a lot of heat input and smelting of ores. Another issue is the Sustainable Development Goals of the United Nations, which again, people feel very committed to, say that we need to be able to provide affordable and accessible energy to those people that don't have it. There are many millions of people in the world that don't have clean cooking fuels or access to electricity. And so the question is, how do we do that? How do we do it reliably and keep things going, still addressing the issues of emissions and carbon, but in a way that allows us to take advantage of the existing infrastructure. It would be very costly to abandon prematurely the infrastructure for things like pipelines and power plants and so on. Now, next slide, please. There is a way to think about this. It's not the linear economy, which was use and dispose. It's an extension of the circular economy, which thinks of 4 R's: reduce, reuse, and recycle, but adds a 4th R to those 3, remove. Reduce is where most of the work has already been done in dealing with emissions, energy efficiency, renewable energy, and nuclear energy. And all of these things actually have very strong support in the MENA region. Saudi Arabia, for example, has one of the largest green hydrogen projects underway in the world, and so on. Reuse and recycle looks at things like enhanced oil recovery, using carbon dioxide to create other chemicals, carbon to fuels, carbon to other materials, carbon cured concrete, for example, which could be a very useful way of strengthening concrete and disposing of carbon at the same time. But very importantly, the idea of remove. And remove includes things like mineralization and storage of CO2, direct air capture, pulling it right out of the atmosphere and doing something with it, and nature-based solutions like ocean seagrass, mangrove coastal restoration, and forestry onshore. Next, please. In order to look at this carefully, KAPSARC organized something called the CCE Guide, and we worked with the International Energy Agency, the International Renewable Energy Agency, the Nuclear Energy Agency, the Global CCS Institute, and the Policy Office at the OECD to do a series of reports on what are the opportunities, key opportunities in reduce, reuse, recycle, and remove. We also looked at cross-cutting issues like hydrogen, very important, I think, opportunity for shifting fuels, but still relying at times on wind and solar to generate that hydrogen, but also possibly natural gas and other hydrocarbons that can do the same thing. Next slide, please. This idea was endorsed by the G20 countries at the summit that took place in November 2020. And what the G20 summit leaders said was looking at all of the options and recognizing the importance of reducing emissions and taking into account national circumstances, that the 4Rs approach was actually a good one, not just for oil producing countries, but for oil consuming countries as well. It's voluntary, it's holistic, it's integrated, it's pragmatic, and it still provides, I think, better opportunities for economic growth than some of the other scenarios that have been suggested. Next slide, please. Another development that took place that I think underscores the seriousness of producers, including countries like Canada, Norway, Qatar, Saudi Arabia, and the United States, is the formation under the leadership, actually, of the United States at President Biden's climate summit that was held just a little while ago, is to encourage oil-producing countries to look at a broad range of mitigation and adaptation strategies, trying to abate methane flaring and releases during production of fuels, the circular carbon economy, which I just described, but is really useful in all countries if they would like to pursue this more holistic approach. Hydrogen, as I mentioned, and a very important one, which I think needs to be addressed, certainly in the MENA region, but all around the world, is diversifying the economies of many countries away from very high reliance on hydrocarbons. Next slide, please. And in fact, this is really the last thing that I want to mention. The circular carbon economy framework has three major pillars to it. It's advancing the technologies associated with the circular carbon economy through research and development and pilot projects, providing enabling mechanisms through government regulations, and even financial incentives and so on for deployment of new carbon management technologies. And critically important to, I think, people believing that this is a viable approach is developing very robust and transparent measurement, reporting, and verification systems for the carbon offsets that are likely to play a strong role in going forward. So Yukari, thank you very much for the opportunity, and thank you to the International Association of Energy Economics. Back to you.
Thank you, Adam. I also have two questions for you. This circular carbon economy is a new concept. So although you have already explained how, I would like to know further how G20 members received this new concept, and any difference in the reaction among the energy producing and consuming countries?
Yukari, that's a great question, because I think a lot of people tend to look at this as some effort to by oil rich countries to avoid dealing with climate issues and the problems associated with emissions like carbon dioxide, but methane and others as well. Mm-hmm. And I think that when the discussion first started, we saw a lot of that. There were countries that the circular carbon economy approach, for example, says countries that want to pursue nuclear options really should be allowed to do that. Frank talked about Bill Nye's advocacy for fusion. Former Energy Secretary Ernie Moniz has talked really strongly about small modular reactors as another possibility for the nuclear area. And I'd like to point out that pursuing at the beginning of the discussions at the G20, there were several countries that said, oh no, we don't like the nuclear option. We're opposed to that. And we don't want to endorse the idea of countries pursuing the nuclear option. Ultimately, I think when the discussions went further along, what literally every summit leader said and endorsed on this was, let's use all of the options that we have available. Let's use all of the tools in the toolbox to address this critical problem. Let's not leave some solutions lying on the table because one country doesn't like nuclear and another would like to pursue it, just as an example. And eventually everybody came around and said, you know, a holistic approach, which allows for all of these options and maybe new ones that we haven't even thought about yet, new technologies, should be pursued and should be pursued vigorously. And what we need to put in place is the technological effort, the government oversight, and the measurement and verification systems that will really drive this forward. And I think that'll be the next steps as we go out into the future. Thank you.
Oh, I see. So that this is since the concept is holistic, it is a toolbox actually with the lid wide open. There are any other new technologies to be able to add it into the future.
Right, and I think in all fairness, Yukari, the real question, I think, and it's a legitimate one, is how do we get the enabling mechanisms in place to drive this forward? How do we create the financial and other commercial incentives to make it work? And how do we make sure that countries are delivering on the promises they made in Paris in 2015?
Right. We have so much work to do, actually. And then that brings me to the next question. I must ask you this question as your presentation highlights the G20 leaders' endorsement of the circular carbon economy. What is the reaction to the recently published IAEA's report? Although I think you mentioned already on the net zero roadmap. I understand that it was heavily reported by news around the world that IAEA has strongly recommended to stop any upstream investment on oil and gas immediately. Although this is a kind of exaggeration, but how do you react to that?
Well, the EIA, the International Energy Agency, the IEA, presented one scenario, one pathway really, that really could be a risky one for both consumers and producers, because the idea that we may be able to get by with no further investments in oil and gas depends on many other assumptions and projections coming true. I think that there are probably other climate scenarios that could achieve similar results that might be less precarious than that one. And I'll come back to the circular carbon economy idea. The CCE options, reduce, reuse, recycle, and remove, offer a lower cost approach and I think a greater probability of success. I think the IEA could have painted a fuller and richer picture of climate pathways, and I suspect that we'll see more from them along those lines.
Mm-hmm. Okay, as you mentioned, we still have about 1 billion people still waiting for the access to the energy, and then also 2 billions more to be born by 2050. So we need to have all the options available, and I think I understood that the CCE, the circular carbon economy concept, is to make that option, how to say, open for all the world. Thank you very much, Adam. Thank you. So now I will move on, and let me invite our third panelist, Professor Jean-Michel Glachant, Director of Florence School of Regulation, EUI, Italy. So now the floor is yours.
Ladies, gentlemen, what's new in European energy transition? If you know already European Union till 2020, we are just a level up, a full world up. If you do not know anything, I'm going to introduce you. 4 levels: the European institutions, the member states, the businesses, and the citizens. European institutions, they use targets, strategies, and laws. The target: the 3 core EU institutions, Commission, Council, Parliament, agreed to reduce our binding targets to a single one, greenhouse gas emissions, and they agreed to put it at -40% in 2030. But last year, in the middle of the crisis, they changed their mind and they put it at -25%, which is very demanding, much more than 40. Strategies. Strategies are mainly for European Commission, not knowing if Council and Parliament will follow. Commission has a general strategy called Green Deal, which covers many sub-areas as mobility, buildings, agriculture, environment, circular economy, renewable research and innovation, with a vice president leading it. And on the top, several sectoral strategies giving vision for sectors, like 2 examples. Offshore wind strategy. Commission targets 50 gigawatts of offshore wind in 2030 and 300 gigawatts of offshore wind in 2050, making 800 billion euro investments. Hydrogen strategy. Commission targets a pilot of 6 gigawatts producing 1 million ton green hydrogen in 2024 and 40 gigawatt electrolyzers producing 10 million tons green hydrogen in 2030. Laws. Without laws, nothing works in Europe because Commission has limited executive power on member states. So we need laws. Commission is preparing an enormous law, the climate law, which will tell how Europeans will reach their -25% greenhouse gas in 2030 and how they can promise to deliver net zero in 2050. This core law will touch about 12 other laws explaining how to implement in details, for example, norms for buildings, norms of emission for cars. That's the European institutions level. We have just seen European institutions, and now member states. As you may not know, they are the member states implementing the targets we have, the single target we have, minus 55%. How do they do? They produce national energy and climate plans for the 10 years ahead, presently 2021-2030, in which they show freely the energy transition mix, energy efficiency, building refurbishment, heat pumps, biogas, biofuel, renewable power, gas substituting coal, CCS, etc. These 27 national plans are checked by European Commission to see if we reach our unique binding targets, unique greenhouse gas emission. But we have a new level for greenhouse gas emission, minus 55. All the plans we have been conceived for the old target, minus 40. All the plans are to be redone. But Commission has a lot of money to put on the table. We just decided last year the new budget 2021-2027, 1,000 billion euro with 30% for energy and climate actions, which means 300 billion. On the top, last year, we also decided to have a common European recovery facility with 672 billion money. Each country can send to Commission a recovery and resilience national plan offering at least 37% of energy and climate actions, which means at European level, 250 billion. If you sum it up, we have at European level 550 billion direct budget ready to finance energy and climate. European Commission used to say that 1 million euros spent in the European budget triggers 2 million in national budgets and business community. So in EU, we roughly have 1,500 billion ready to finance our ambitious 2030 target. It should work. We have seen European institutions and member states, but what is the business community to do? Many things, because many new businesses are created by the public policies. Let's take the most obvious one, renewables. How much renewables should we produce in the EU to reach the minus 55 demanding target? We should produce 120% more renewable. We have more than to double the renewable production in the coming decade. We need 170 gigawatt more wind. We need 200 more gigawatts solar. You see how much businesses are open, but they are only to clean the existing electricity consumption. Many other things have to be done. Cleaning of mobility, electrifying the cars. If we want to electrify all the cars, we need to produce 1,100 terawatt hours more of clean energy, which is what we will be producing. We need also to decarbonize heating and cooling in the building and service sectors. We need to decarbonize aviation and shipping. We need to decarbonize industry itself. All these other parts of energy consumption being not yet foreseen renewable in 2030 make 4,700 terawatt hours. It means 3 times more than our renewable target for 2030. We have to double renewable to reach 2030, and we have to do 3 times more to decarbonize everything. It creates an enormous attraction for green finance. The biggest German bank, Deutsche Bank, says that it will invest 200 billion euro in green financing. The EU carbon price has doubled last year in the biggest economic crisis ever seen since World War II. European Commission is preparing a full taxonomy for green finance to give investors the certitude that they invest into something durable, sustainable. The chairwoman of the European Central Bank is calling EU to create its own internal open green finance market. You can check it by seeing many green majors appearing in the EU. Enel targeting 150 gigawatts of renewable in 2030. Total, the oil and gas French company, targeting 100 gigawatts in 2030. British Petroleum targeting 50 gigawatts in 2030. The 6 major of green actions in EU, utilities or oil and gas, are targeting roughly 500 gigawatts of renewable in 2030. My God, it's really big business back. Ladies, we have seen European institutions, member states, businesses, but we are in democracy, so citizens. Will citizens like it? The question has to be asked. As consumers, will they ask to pay more to fast price increase? You have seen carbon price doubling. It puts 10% more on the price of electricity produced by gas. And many people are saying that carbon price has to be up 50% more. The EU grids in electricity, DSO, target 700 billion investments till 2030. But will the regulators increase the tariffs? Will the price of renewables themselves go down till 2030? Is it true? Because the levelized cost of renewable is not the cost of integrating renewable. Let's assume that it will work for the consumer. They will agree. What do they think as employees? Will they welcome the jobs shifting or strongly react to them? For example, electric vehicles. Electric vehicles require much less labor-intensive activity and less skills into the manufacturing, the reparation, the maintenance. Let's take coal regions. You have seen Germany giving 40 billion euro to get all coal plants and all coal mines closed by 2038. What will happen if the carbon price is pushing the closure of coal in Germany in 2030 instead? I know that with a carbon border adjustment mechanisms, a carbon tax, we can protect European jobs from pressures coming outside because of our internal costs increase. But first, this has to be agreed by China, India, US, not done yet. Second, it will only stop foreign countries to put more pressure. We will have exactly the same internal pressure on jobs and skills. As you see, not done yet. Conclusion, we have a new European policy, very ambitious but doable. We have the budget to finance member states' actions. We have the business community really ready to put hundreds of billions into this gigantic transformation. But will the consumers, will the labor force agree, or will they react strongly? Will we get someday a European President Trump breaking it all?
Oh, thank you, Jean-Michel. We hear a lot about the rosy picture of green recovery of Europe, like business opportunities, green finance, and new jobs, etc., etc. But you pointed out that the reaction or reception from citizens, consumers, or laborers may play the key role in the success of this EU strategy to meet the net zero landscape or target. You are concerned about higher energy prices or carbon prices, job loss in the traditional sectors, no permanent jobs among newly created jobs, and less skills required. So what do you see it's necessary to be done if these concerns are to be addressed?
Thank you, Yukari. I would like to know what should be done. I can only say the difficulty in Europe, policies for redistribution for non-flexible consumers, consumers unable to change the way they consume because they cannot invest in other devices, they cannot buy another flat, etc. Redistribution is only national. It's not a European power. Training, retraining of labor force is only national. The European level cannot do much except symbols. Pushing innovation, pushing new industry, new technologies, again, it's national. Helping social mobility, helping regional mobility, again, it's national. What the European level can do is opening the wallet at European level, give 550 billion to national governments, but national governments are mastering the policy. So in each country, it is a national government which will drive this social compromise between energy transition and people. Second, each policy we may decide at national level only will take time to have effects. So it will be easy to blame European decisions while people are not seeing things changing. So we have no guarantee. It's a challenge or even it's a gamble, but we will see.
Okay, so it really is, how to say, the task is left with the national governments and also and how the citizens react to that or get used to that or change their ways of living. Okay, fingers crossed. Thank you very much. So it's not as rosy as we hear outside Europe. That is what you are pointing out, I think. Maybe away from your presentation, but how do you think the members of the IAEE can contribute in addressing this huge challenge of energy transition, or not limited to the things in Europe or in the world?
Yeah, but first, I love IAEE, and you know it because you have been our president, and I like what we do, and I like everything we do, but we have many things to do, we can do more. First, all the basics of energy economics, we can use to do reverse engineering, knowing the future we would like to reach, net zero. It does not matter if it is 2050, 2060, like in China. What are the existing policy tools we can use? Adam was saying, we have already pragmatic tools. In Europe, we have more constraints, etc. In US, with President Biden, they are testing many things. So we have already a good set of tools, but we have to use them in the reverse order, knowing the target, how to go there. Jim Smith, 2 days ago, or today's president after you, was saying we have to remember in any use of energy policy tools that there is hidden factors being very important, externalities. And even Frank was using externalities a few minutes ago. So we have always to add externalities to our tools and opportunity costs. We do something, by doing this, we do not do something else. So we have to think about this. And these are the basic way of using our tools. We may add new tools. For example, experimental economics. 2 economists got the Nobel Prize last year or the year before. Should be the year before. Esther Duflo and her husband Banerjee, because they are saying we have to experiment with depressed area, depressed people. People frequently knows better how to get out of their mess than us. So we have to see with them through experiments. But we have to go to other areas of economics of innovation, economics of digital economy and platforms. Because if we want the full digitalization of consumption, we have to understand how it works. Even economics of human capital, and very obvious also, economics of taxes, of public spending, economists of industrial policy. In a session this afternoon or this morning, Carsten Neuhoff, an economist from Germany, was saying, in fact, we do not need an energy policy. We need an industry policy, because it is the industry which will make it and not the energy itself. And to end, we also have to think geopolitics and even socioeconomics. So we have many things to do, and we are ready to do it. And it will require for us fantastic work, because we are doing something for the better.
Oh,
That's
thank
the
you
way
very
I
much,
see it, Yukari.
Thank you very much, Jean-Michel. So we are facing challenges, but that is also the, how to say, the task in front of us energy economists to look further into the wider range of economics to meet, how to say, to attack these challenges and address the issues. So thank you very much, Jean-Michel, again.
Well, thanks to you, Yukari.
Okay, we will come back to you again later. Now, I would like to move on. I turn to the fourth panelist, Professor Debajit Palit, who is a senior fellow and director of the Energy and Resources Institute, known as TERI, India. So I would like to ask Palit, Dr. Palit, to have the floor.
Hello, everybody. Let me at the outset thank the organizer and the IAEE for giving me the opportunity to speak at the plenary session. Today, my presentation would be on the energy transition in India, a summary of the findings that my institute, the Energy and Resources Institute, has carried out its work in the last few years. So in context, India has committed to the Paris Climate Agreement, has reduced emission intensity of GDP by 33 to 35% by 2030 from the 2005 levels. It has also committed to increase the share of non-fossil fuels to 40% of the total electricity generation capacity. The target is 175 gigawatt of renewable energy by 2022 and 450 gigawatt by 2030. While the renewable energy generation has increased considerably during the last 5 years, with more than 100 gigawatt solar capacity installed or under installation or bidding, however, fossil fuels still continue to account for 60% of the total installed capacity in India. Improvements in the transmission network infrastructure have also aided integration of renewable energy. But despite increasing integration of renewable energy and achievement of near universal energy access in the rural areas, providing affordable, reliable three-phase power supply and adoption of clean cooking remains a challenge in India. So in terms of energy transition in India, based on the public procurement of solar and wind energy, has discovered that solar electricity at INR 1 rupee 99 paisa per kilowatt hour and wind electricity at INR 2 rupees 44 paisa per kilowatt hour are the cheapest electricity in India, but only when the sun is shining and the wind is blowing. A small amount of somewhat farm renewable energy, which might include solar plus batteries, may be available at a price competitive with coal electricity by 2030. Electric buses running at roughly in Indian rupees 25 to 40 per kilometer are currently cheaper than the electric or CNG, cheaper than the petrol or CNG buses in providing urban mobility services. So our analysis indicate that electric two-wheelers and three-wheelers are cheaper on a per kilometer basis than the petrol models or diesel models. And electricity is cheaper than diesel or any other petroleum products for industrial thermal use. So to take an example, solar costs have fallen by a factor of 5 and are now decisively cheaper than coal in India. And which I just mentioned that we can get solar electricity at 1.99 rupee when the sun is shining. Round-the-clock bids have also delivered low bid prices, but they rely more on oversizing and resource complementarity rather than storage. So the model project that has been set up to reach 400 megawatt of round-the-clock renewable energy with 80% annual capacity utilization factors requires oversizing by a factor of 3.3 to 3.5 and relatively very less storage. Electric buses and two-wheelers are less expensive than petrol and diesel, and based on open bidding system, we have found that while the diesel buses operate at a cost of INR 60 to 80 per kilometer, electric buses are now available without any subsidy at 30 to 55 rupees per kilometer, and that's the that's the total cost of the system, including the capital cost and the operating and maintenance cost. Now, in the case of industry, taking an example of forging industry, the replacement of the furnace oil-based furnaces with electric induction billet heaters could be a major way to achieve cost effectivity and also energy efficiency. So the cost of heating can be reduced from roughly around INR 9,300 per ton to INR 5,100 by switch over to electricity, and the simple payback period comes to about 2 to 3 hours. And these also have other benefits, including reduced maintenance, almost no scale loss, quality improvement, no air pollution, which is a major challenge in India, and increased productivity. The transition pillars, based on the analysis that we have done. So what we are observing is that energy efficiency in India continues to increase, largely driven by technical energy intensity reduction across sectors. The renewables are emerging as the electricity source of choice. From a system perspective, renewable energy is already cost effective or would be cost effective before 2030 by including, say, storage. Electrification of fossil fuel use, example in transport, will accelerate, especially as a system-wide cost effectiveness increases. Green hydrogen and biomass-based fuel will also predominate in applications where electrification is not viable. And this shift will depend on international carbon emission reduction efforts. We are also saying that resource efficiency in user sectors driven by economic considerations would increase substantially and lead to further decline in energy demand. So if you see the total final energy intensity of India's GDP has fallen almost 30% since 2011, and we have committed that it should get reduced by 35%, 33 to 35% by 2030, which is very much achievable in case. In terms of renewable energy, even at today's cost, the renewable energy systems of 35% are the cheaper due to the substitution of fixed and variable costs. So if we substitute them also at the current cost, then also they are becoming cheaper than the thermal and thermal energy. So the energy transition on this scale, that means on using renewable energy, would drive a demand, but achievable growth in electricity demand. So we are quite confident that the renewable energy can also meet the growing electricity demand in India. So our assessment of the energy transition, based on the analysis that we have done in the last 2-3 years. So what we can say is that for India, renewables will continue to be the overwhelming source of capacity addition for electricity generation. The coal demand may rise till the late 2020s. However, the need for additional thermal capacity is extremely dim. In fact, since 2015, as far as I know, no new financial sanction has been provided by the government to the government public sector undertaking to initiate any coal-based power plant in India. The farm cost-effective renewable energy would be viable by 2030. However, the speed of price reduction of batteries will determine when this occurs. So if this price reduction is fast, we might achieve or cost-effective renewable energy much before 2030. But if the price reduction is slow, then probably by 2030, we'll definitely the renewable energy would become viable, including the batteries. Almost all, that's about more than 80% of the new vehicles in urban areas in 2030 will be electric. That's a projection we are making, or based on hydrogen and fuel cells. The gas-based cooking, whether it is LPG or piped natural gas, and electric cooking will be dominant by 2030. While India has achieved almost universal clean cooking by providing LPG connection to all the households, and in urban areas, PNG connection is being scaled up. The electric cooking is yet to take shape or mainstream, but then there are challenges of adoption remains, as I said in my first slide, because of income inelasticity. So that's why we are not clear about the speed of electric vehicle transition in rural areas. In urban areas, we are quite confident that almost 80% of the new vehicles by 2030 will be electric, but in the rural areas, we are still not clear, primarily because the electricity reliability and quality continues to be an issue. And hopefully, if the reliability and quality of electricity is addressed in the rural areas, the speed of transition in case of electric vehicle will also be faster in rural areas. The speed of transition to electric cooking, again, because of the reliability and quality of electricity supply is still a question at this one. And we hope that sooner than the later, the quality and reliability will improve, and we'll see a transition to electric cooking in rural areas also. The nature and speed of the energy transition in the industry sector is also something that we have to look at, where we are not very clear about how it is going to happen based on the analysis that has been done by TERI. In continuation with the assessment, in the rural areas, despite near universal electrification, the income constraint reduces the elasticity of the user to support higher consumptive loads like electric fan, cooling applications, or heating applications, or maybe electric cooking. So energy efficient devices promoted with incentives and demand side management to keep monthly electricity charges low will be the key for the success and the transition toward a cleaner economy. PV-based electricity for agricultural pumping would be dominant before 2030. That's the analysis say, but we are not clear about the level and speed of penetration. While PV-based agricultural pumping is already cost effective and will be the preferred option, especially as excess electricity is brought from farmers or low tension level PV generation is set up at rural substation. And most importantly, it has the potential to revitalize the finances of the electricity distribution sector, thus contributing to the faster energy transition across the sector. Because if you have a vibrant electricity distribution sector with adequate profit, then they can invest that money back to the system for a faster energy transition. And we are looking to this model of PV electricity based agricultural pumping, where solarization of the agricultural feeder are being done. And we hope that this will be a pan-India level phenomenon in the years to come and could revitalize the finances of the distribution sector. Thank you very much.
Well, thank you very much for sharing the research results, Debajit. I have two questions for you. According to your research, India will focus on energy efficiency, electrification, and renewables. You picked an example of PV electricity-based agricultural pumping as potential driver in the rural area, even to revitalize financing of the distribution sector. Are you talking about distributed system in terms of electricity here in comparison to a centralized system, or Indian government is aiming at connecting all parts of India to centralized electricity system?
Thank you, Yukari. So what we are looking at is that, well, India has already connected all the villages to the national grid. So in India, we now have one country, one grid concept with all the villages and all regions being interconnected. However, having said that, a new program has recently been started with trying to solarize all the agricultural grid in the country. So the the distribution grid which are connecting to the agricultural pump sets. As you might be knowing, in India, a lot of irrigation is happening through extracting groundwater through electric pumps, and these are all and these electric pumps by the farmers, they is highly subsidized. So in many states the farmers do not pay anything for that. In some states they pay very extremely less amount, and that's the political economy of the entire energy sector. And because of that, there is a huge losses, financial losses for the electric distribution company. So the one way to address this solution that many researchers have proposed, and what the government is trying to do, is to solarize the agricultural feeder. And because solar is something that is available during the day and you don't have solar in the night, so you need to have battery storage. But in case of solarizing the agricultural feeder, you don't have to have the battery storage, because you can extract the water and use it during the daytime. And that's how the things are being worked out. A public sector undertaking has recently done some solarization of the feeder in one of the states, Maharashtra, which has the highest loss from agriculture in India. And they found that they can actually supply electricity to the farmers at a much lower cost than the current cost to supply. And in a way, it would be a notional profit for the distribution company. And if that can be expanded to the other parts of the country, then it has the potential to revitalize the entire distribution sector. Because if you don't lose money, that in a way is also contributing to your balance sheet, to your bottom line. Just to give a number, the aggregate power subsidies in India is almost like for agricultural consumption is almost like $8 billion US. And if we can address a large chunk of it by solarization, and with investment in the solar industry, because it can be done, and solar now being available at a price lower than the thermal electricity. So we feel that it has a potential to completely change the way the electricity sector in India is.
Oh, I see. So the incentive is stimulating the speed, accelerates the speed of penetration of the solar technologies into the rural area. But then you have to actually support this financing so that it will be to reach the target by 2030 and then beyond that. There is a question from the floor, so if there is a time later, I will ask you about it. So please study that. Okay. So I have another question. For sectors and usage where the electrification is not viable, you mentioned the importance of green hydrogen and biomass-based fuels. What about the blue hydrogen, the generating hydrogen with the CCS attached, or blue ammonia, which are part of Adam's CCE, the circular carbon economy? Any chance for India to consider those as transitional energy?
So what our analysis modeling exercise say that, well, today gray hydrogen is available at an average cost of $2 per kg. Now, if I have to go to blue hydrogen, this one, we are not very sure about the storage part of it. We are not very confident or where we have to store it, or things are not very clear. And by 2030, our research says that green hydrogen is expected to become cost competitive for at least for some industries. So what we're trying to say is that maybe we can directly shift from gray hydrogen to green hydrogen. It is possible. But having said that, if in the years to come, so in the next 2 or 3 years, if we are becoming more clear about the storage part of the gray hydrogen, then probably it can also be tried. But at the same time, this is based on natural gas. We are again not sufficient in natural gas. We are importing natural gas. So probably in the long run, we have to shift to green hydrogen because energy security would challenges would also be there with blue hydrogen.
Okay, we'll see if we have more time later on to discuss that, including Adam then.
Yeah,
Yes,
I
please go
quickly add
ahead.
a point. Quickly add a point. In fact, during the financial budget of this year, the government has already announced to launch a national hydrogen energy mission from for generating hydrogen from green powered sources.
Oh,
So
I
some
see.
amount of been allocated, and but the program has not yet been launched officially. It has just been mentioned in the budget. Hopefully, maybe because of this pandemic, it might get a little delayed by a few months, but I'm sure that during it will be launched.
Okay. So I gather that India is really striving to utilize the renewable energy towards the future. So thank you very much, Debajit. So now I would like to invite our final panelist, Professor Xiaoyi at the center, at the Center for Energy, Petroleum and Mineral Law and Policy of University of Dundee, Scotland. So the floor is yours.
I'm Shawn. I'm from the Center for Energy, Petroleum and Mineral Law and Policy at the University of Dundee in Scotland. It's a great pleasure to be on today's panel. So my topic today is about China's new energy landscape. In this my 10 minutes, what I'm going to discuss is first we will start with a brief review of where we are in terms of the energy mix before laying out some of these elements of the new energy landscape. And then finally, I hope to provide a few remarks on the challenges and the discussion. All right, so this is the China's primary energy consumption to energy mix by field type from 2010 to 2019. So sorry, I didn't have the latest data on 2020, but I think it tells the story. So what's striking here is actually the coal, the declining share of coal in China's energy mix is declines almost 13% from 2010 to 2019 in the total energy mix. A caveat here is because of China's total primary energy consumption has increased, the absolute value of the consumption of coal has actually increased. Now, the obvious winner of this is the renewables. From 2010, it was negligible. Now becomes 5% of the energy mix. And then the other obvious winner is natural gas, has more than doubled from 4% to 8%, just in terms of the share of the total primary energy mix. This is the picture for the electricity generation by the field types. Almost the same story, although coal has a larger share from 77% to 65% in this 9-10 years. So the latest data from last year, actually, the primary energy, the coal, has further declined to 57% in the primary energy mix. Now, this is the carbon intensity over these 10 years. So this carbon intensity is the carbon dioxide emissions divided by the GDP in the real dollars. This is over these 10 years, from 2019 to from 2009 to 2019, the China's energy carbon intensity has declined by more than 50%. Over the last 5 years, I have looked at this number. Over the last 5 years, it also declined by another by 20%. So that's the sort of the brief review. Now, what caused this carbon intensity decline is obviously one is because of the structural change, the industry structure change from heavy industry to less energy intensive industries. The other obvious reason is because of the change in the energy mix with more renewables and more natural gas. Now let's look at the the new energy landscape. So in September last year, President Xi announced that China will commit to net zero or carbon neutrality by 2060, which surprised many of us, including myself. This target has two stages. The first stage is by 2030, China will reach the peak energy, peak carbon emission by 2030, and then reach carbon neutrality by 2060. Following President Xi's announcement, there are a lot of policy developments and as well as some academic research. Central to these policy developments is the 14th five-year plan. So China still uses the five-year plan system. The 14th five-year plan covers the period of 2021 this year to 2025. So this year is the first year of the 14th five-year plan. So this 14th five-year plan actually effectively lays out the key targets for the energy landscape. So this makes my job easier. So among these, some of these targets, you see, one is reduce the energy intensity by 13.5% compared to 2020, and then reduce the carbon intensity by 18%. That means there will be some further increase of the share of renewables, the low carbon energy mix to reduce the carbon intensity. And increase the share of non-fossil fuel resources, the low carbon resources, namely the renewables, hydro, and nuclear in the primary energy mix from currently about 15% to around 20% by 2025 and 25% by 2030. So 5 percentage points increase in the next 5-year period, and another 5 percentage points increase by another 5 years. So specifically for each of these energy resources, obviously this will be a boost, a significant boost for renewables. Renewables will account for over 50% of the incremental and primary energy consumption, and over 2/3 of the incremental electricity consumption by 2025. It will be a limiting factor for the coal. The coal will be the loser. But over the next 5 years, it is still expected coal-fired generation, there will be still some further increase, although the increase it is expected to be slow and then decline after 2025. Hydro and nuclear being the low carbon resources are expected to have some further development, particularly for nuclear. The installed capacity for 2025 will be increased to 70 gigawatt from the current level of about 51 gigawatt. So that means over this 5-year period, almost 20 gigawatt increase. So that's like 4 gigawatt a year almost. Oil and gas, it did not specify specific numbers, but mainly lays out some policy statement, and there will be some further gas pipelines and gas storage. Electricity, the power grid, there will be some further increased utilization of the ultra low, ultra high voltage grid, and then develop pump storage and other energy storage facilities. The policy measures, there are some specific policy measures, particularly for this year. There are already some specific policy movement on this in terms of for carbon trading from the 8 pilot carbon markets to national carbon markets. And then there are new pricing mechanism for pump storage. In this energy landscape, so this map shows the nine major clean energy bases. So in terms of the spatial development, the spatial plans. So by and large, is in the northeast or the northern China is the solar and the wind. So this is wind, this is solar. And in the northwest is solar, wind, and some of the coal-fired thermal plants. And the hydro will be mainly in the southwest, and there will be a few offshore wind projects. So there's the sort of the spatial geographic distribution of the energy bases. Now let's talk about the challenges. So the first challenge is obvious, it's about the technology. Like any other countries. Currently much hope for reaching carbon neutrality by 2060 or by 2050 is in the some sort of breakthroughs in technologies that are currently in the demonstration stage or the pilot stage that are not yet commercial. Things like the CCUS, hydrogen, or energy storage battery. Now, one good thing for China is in China you can see China has the demonstration projects for almost all of these technologies, CCUS, hydrogen, and battery, and it's accelerating the sort of demonstration projects. So there may be some sort of breakthroughs. I don't know. The second challenge is the increased share of renewables and energy security. The energy security has always a main concern in China's energy policy. So traditionally, the energy security concerns has mainly focused on the oil supply security. Now, with the increased share of renewables, there could be a shift towards particularly on the electricity supply. So one thing is what would happen if there is a Texas type of the blackout, and because China's electricity supply for over the last several years or almost last several decades, couple of decades, have been very good. The very good access. But what would happen if there is a blackout? So will public tolerate this? Or what would the public willingness to pay for the sort of the increased price? Now, on the positive side is that China obviously is a big market and has this sort of very connected, centralized operating, centrally operating grid. So that grid provides sort of more opportunity to mitigate the intermittency issues. Some of these intermittency issues may be canceled out. The last challenge, the main challenge, what I see here is the sort of the system China's currently, those targets, those plans are from a top-down approach, is driven from the top. But in reality, in operations, many of these operations will be nailed down to the provinces or the local governments. So the local governments, like the provinces, may not have the incentive to reduce the coal-fired generations in order to import the electricity from the northwestern part of China. And for good reasons, because these coal-fired plants actually provide the employment and provide the sort of the industrial output also for the sort of electricity reliability. So that could be some sort of conflict there. Although the market-based reform in electricity industry has been has been progressing from the pilot. There are a number of pilot markets there, but there could be some sort of potential conflict. I think that's all what I need to say for these 10 minutes. Thank you for listening.
Thank you, Xiaoyi. I gathered from your presentation that even in the national plan, upstream development of oil and gas is expected to continue for China. And combining this with possibility for local governments of coal-rich regions continuing to develop coal or to keep using the coal-fired power plants, it seems very challenging for China to become net zero by 2060, even if carbon intensity seems to have been declining for the last decades. But there must be an assumption that negative emission technologies to play a key role in meeting the net zero target. What do you say?
Thank you, Yukari, for this excellent question. I think, to say it's very challenging to reach the carbon neutral by 2060 is probably a polite way to say that. The reality is, I think, is too much hope is on the second stage, is from 2030 to 2060. Many of these technologies could develop. It's somehow like the IAEA's the roadmap. So many of these technologies, hope on these technologies. I think from the policy circle is probably is just we don't know exactly how we are going to achieve it. Is because it's still some 30-40 years away. But yes, I think it's a lot of hope is on this negative the carbon emissions like the CCUS, or some people say about this sort of growing, planting more trees. So the forest, right? So that's a carbon sink. I don't know how much, how many further acreage of the land we have to grow so many trees. So on the CCUS, I think it's hopeful. One thing I find is a little bit irony is, see, if the CCUS is can be made more commercially available, and then there is not much need to reduce coal if it can be right. So on the oil and the gas, I would certainly think is at least for the foreseeable future, China is still hoping to grow the oil and the gas, particularly on gas. Obviously it's an issue to address some of the local environmental problems during the heating seasons. In the big cities during the winter time, the local pollution is a major issue. Oil, I think is still just like in terms of the energy security has always been a concern. I don't see very much, at least in the foreseeable future is trying to develop it. But on the other hand, the limiting factor for oil is the domestic resource is limited. So there are not much potential on this. So that's why there are some policy announcements about the to open some of these acreage is how successful is another story, including like the earlier, with regard to the shale gas development, China, we see a lot of this sort of assessment. China has, in theory, has a lot of potential for the shale gas, but actually, the production is quite limited and nothing comparable to the U.S. So yeah, so I think it's it is quite challenging.
It seems that China is still keeping the diversity of energy mix, and yet we cannot really see the official numbers because the China is following the 5-year plan. So I see that there is a lot of, how to say, the opportunities to contribute for the researchers, for the researchers to play a big role on filling in the gap of that, you know, how that will happen, that by 2060, China will achieve the net zero. So for those IAEA members who are conducting research on China's energy mix, what area of research would add value to address challenges in place?
Yes, that's a good question. You know, personally, I think one area of the specific area that China, researchers can, particularly for the IAEE members, the energy economics or policy, this circle can look at, is the look at the specific those pilot projects. Many of these sort of pilot projects, whether it is in the some smaller products, demonstration projects like the CCUS or hydrogen, or the China also had to that the IGCCs, these technologies, so to get some more concrete data and to analyze their the sort of the challenges, and then when they can make a business case. So the challenge there is often how do you get the data. So sometimes the data is quite difficult, and some of these company reports you need to be very critical. For example, I have one student looking at this issue in the CCUS and in Wang, in Xinjiang, in the northwest, and the numbers just does not add up. It's it's like I say, one ton of CO2 can get out, or can increase the oil production by 1 ton. So that's the sort of, and then also same thing with electric vehicles. So many of these things. Also in terms of the policy pilots, so there are policy pilots, and actually it's produced a lot of data, on electricity reform, and further on the oil and gas. My sense is oil and gas is more difficult because oil and gas is more concentrated. So that's an area I think is probably we can be more productive. A lot of people doing this research on this, the pathways to get to the carbon neutrality, because President Xi announced in China, the President Xi said something, it means something. Everybody want to do it. I'm not a big fan of this because a lot of these things are based on assumptions. So just like the scenarios, we all know the scenario is based on too many assumptions. But it's usable for policy analysis.
Okay, thank you very much. So you actually do mention something similar to what Jean-Michel pointed out, that there are many opportunities for the different kinds of economics to play a role, even in understanding all these pilot projects. And then you mentioned the data is key to those, and then there are also the reactions of the consumers, which have to be understood. So we all have similar challenges in front of us, but it is also the big field for the economists to play more important roles. So thank you very much, Xiaoyi. Now I would like to go to the general questions for discussion. Let me turn now to this question about the COVID-19. Nobody has so far mentioned the influence of the COVID. Experiences from the COVID has changed anything or not. I do believe that it has influenced the people's life, and it has also influenced our basic values and ways of thinking. I suppose it has also influenced our stance towards climate change issues. Would any one of you would like to raise any point in relation to COVID-19 and achieving carbon neutral target? Those who volunteers, please raise your hand. I will ask you to respond to that. Any relationship or anything relevant to this carbon neutrality, meeting the carbon neutrality target because of the experience. Okay, Frank. Your mic is muted.
Sure. I just wanted to give a plug to a paper that we did looking at the lockdown period that occurred in Italy. And what we were able to do there is that Italy has a share of renewables share normally very similar to what exists in, say, California. But during the lockdown period, demand fell significantly. And so what we were able to look at was what is the impact on the operation of their market with a significantly larger share of renewables in demand because the demand fell. And one of the things that we learned is that the from this analysis is that the cost of the failing to recognize a number of the using what's called a simplified zonal markets that exist throughout Europe went way up extremely rapidly, much more rapidly than one would predict during the pre-COVID period. So saying that the cost of having a simplified market design for electricity in Europe is likely to go up significantly as the share of intermittent renewables increases. So that's electricity market implication of COVID.
I see, very interesting. So the demand is expected to go up actually for the electricity as we shift away from the non-electricity towards electricity. But during the COVID lockdown situation, demand went down. It was like an experimental place to understand, what if the share of renewables goes up. That was very intriguing to understand. Debajit?
Yeah, so as far as COVID is concerned, that means I don't see, that means we are not talking about carbon neutral as yet. This one the government has not yet declared, though the government definitely has shown its intention for low carbon pathway, and we are not creating infrastructure, carbon intensive infrastructure in the power sector now. But what I see from a bottom up thing is that the income definitely has been affected because of the COVID. The income of the rural population has been affected because of the COVID, and a large proportion of the consumers being in the rural area, and with, as I mentioned, the electricity distribution companies being at a loss because they are not because this rural consumer are not being able to pay, and COVID has actually exaggerated the situation. And in the last last lockdown and the current lockdown period, the electricity tariff could not be increased. So probably the financial viability of the electricity sector will take a little more time than what we had expected, and which might in the long run also affect our transition to more cleaner energy. So this could be a factor in the short to medium term. This one, and another aspect that we have seen is that in India we are also many of these private sector startups and the civil society organizations are also working with the rural community to put up DRE, distributed renewable energy systems, and which are being financed at the local level. And the rural consumers, the income loss probably is going to affect the uptake of such DRE systems in the short to medium term. This one. So yes, there will be some effect. Whether this effect could be a long term or not, and we won't be able to say right now, but definitely in the short term, it is affecting.
Yeah, yet to see. Actually, I have many questions from the floor, and then the time is running out. Yes, Xiaoyi, you would like to say?
Yeah, because I don't know how to raise my hand, so
I
I
could see you doing that.
So I just raised my real hands. About the COVID, I think one issue is obviously we see, the sort of the behavior impact. So the lockdown, some of this could be more long-lasting, so like the work from home, and then the sort of the conferences, sort of travel. What's also some sort of surprising to me is I think people tend to be overestimating this impact. One thing, last year we did a little survey in China. It's not a very representative sample, but we looked at this, almost several hundreds of the participants. So a lot of people really don't really like to work from home for various reasons, because the China's sort of the working from home, the condition is not as much as like in the Western world, and then and also for some sort of teamwork and social impact. So when we ask the question to the participants how many days you would like to work from home, almost more than 50% is they do they prefer still to going back to work. So I guess it's not too concrete because of the sample with China is small, but still is I think is sometimes people tend to overestimate some of this this part of the behavior change.
Okay, yeah, the behavioral change is very key because as Jean-Michel pointed out, after all, it is us consumers or citizens who will change the way we use energy. Debajit, you have your hand is still raised, but it is the previous one. Is it? Okay. Since I have many questions, Adam is there. So you want to respond to the COVID, or you would like to respond to the question from the floor?
Well, Yukari, your question was about the COVID-19 virus, yeah. But let me extend that to the electronic viruses that are increasingly a problem for countries, and particularly the energy sector. The United States just had a really bad cyber attack on a oil product pipeline. So gasoline was difficult to obtain along the East Coast of the United States. And I think that we need to devise systems that are resilient to pandemics, but cyber viruses as well. So there's a lot to be done. I mean, maybe both of these things are part of this new energy landscape. It's easier to look backward and say that the effects of COVID on energy demand were stronger than almost anything we've ever seen historically back in April, May, and June of last year. And we're only now beginning to recover from those very low levels. And I think, as Shawn said, there are some questions about things like the effects of remote work on electricity demand and fuel demand, because if people work remotely, they might not be driving or taking a train to work, depending on what fuel the trains are on. And then on the other hand, there were some studies that said people's fear of another pandemic makes them want to drive a single vehicle car rather than get on a bus or metro to travel. I think we have a long way to go to really understand the full effects of COVID. Thank you.
Yeah. Add to that, there was some analysis or maybe view that it hit the shared economy concept because we don't want to touch somebody else's has already used car, etc., etc. So the COVID really, how to say, changed the way our lifestyle is, and then yet we don't know if it goes to the positive the influence or negative influence. I have so many questions from the floor, so I actually would like to visit these questions. And the interesting one, each of them is interesting. But Shawn, may I challenge with this question? Many coal-fired power plants built in the last decades will become stranded asset if China is serious to be carbon neutral in 40 years. How large could be the associated cost? Is realistic that China and its power industry will accept?
This is a great question, and unfortunately, I don't have the numbers. I personally, I did not really estimate these numbers. I see some people have this, at least as in the billions of dollars. But one thing is, obviously, see, it's still 40 years, and then one thing we notice is, as we talk today, the main renewables to deal with the intermittency, to deal with the sort of the resource adequacy issue, you will need the fossil fuel, in China basically is coal and some natural gas, to be there to provide the backup capacity. Will the industry accept it? I think it's my sense is that the industry currently has a hard time to accept it. So yeah, I don't know how do we predict with the next 40 years. Yeah.
Yeah, that is the issue actually in many countries. The electric utilities or companies are facing. It is such a radical change of the actually the policies or regulations that we haven't done the study yet. How to accommodate that. So thank you very much, Shawn. There is another question on the power. This is about the power shortage. Debajit, there is a question for you. Power shortages are not uncommon in India. Just thinking about Frank's presentation with higher reliance on intermittent power sources, how do you think India should lower instances of power shortage problems?
Thank you. Well, in India, we have a total installed capacity of 380 gigawatt, and out of that, around 50 to 60% is the peak installed load. That means we are running at almost 50 to 60% depending on the season. This one. So the power shortage is not related to any shortage in electricity generation. The shortage is more to the power cuts. I mean to say the power cuts are more to do with the efficiency of service at the electricity distribution level. So if you can improve the distribution efficiency and the service efficiency at the local level, many of the problems would get sorted out. To give an example, I did my research and tried to find out the reason for this as part of my PhD work. And when I visited the field, I could see the 11 kV grid. This one, it's say 24-hour supply or maybe 22-hour supply, but that doesn't mean that the household is actually getting 22-hour supply, because between the 11 kV line and the house connection, there is a transformer, there is an LT line, and the problems lies there because those are the things that are not being properly maintained. And because the revenue from the rural areas is extremely low, so the electricity utility doesn't have any incentive also to maintain them properly. So if you can address that problem, I think more than half of the problem of power cuts will get addressed there. Now, having said that, if we are increasing renewables, we are also saying that we could have decentralized sub-megawatt scale power plant at the local level, which can serve these feeders, this one, and which will be more decentralized in fashion. And with the electricity service provider, a semi-private type of thing, electricity service provider can probably provide a better service to the rural consumers to address not just this power cut, but also improving the reliability and quality of supply. So that's a model we are working at. What I call it is not just electricity supply reliability, but also service reliability. And that's extremely important at the local level.
I see. Yeah, giving some kind of the ownership also helps to improve the service level.
Absolutely, absolutely.
Thank you very much. I think this is a question from Jean-Michel, but actually it is a question, anybody can answer this question, but maybe I challenge Jean-Michel. What can we do to make the consumers easily accept the effects on the price?
There is no easy answer. I do not believe in it. because first, consumer does not exist. We have consumers. For 15%, 20% of the consumers, they even do not know if they pay more or less. They absolutely do not care. So these ones we can forget. Then we have the opposite, 15, 20% in Europe. 15, 20% of the consumers, they really care because they have just enough to live what they call a decent life with the many obligations to charge the phone, etc., etc. These ones care extremely. So they can riot, not in all countries. In Norway, Sweden, they do not riot, and they do not need to. But in Southern Europe and in Eastern Europe, they care a lot. So what to do? Up to you to find a way. We used to say in Europe that we agree that 10, 15% of the consumers can be subsidized by the other consumers or by public authorities. But they have to be clearly subsidized, and they have to believe that they are subsidized. They have to. So you remember that it's done country by country. So it's not at the European level at all. At the European level, we can do near to nothing regarding this.
Okay. Yeah, but it's
Yukari,
Yes,
you talked
Adam?
earlier. Yes, you mentioned earlier that some scenarios seem very rosy in their outlook, and one interesting thing is the UNFCCC modelers have used something called shared socioeconomic pathways as a way to try to think about how the world could develop over time that would influence the design of the models. And the recent IEA report seems to use SSP1, which is low challenges for mitigation and low challenges for adaptation. And your question about would consumers accept higher prices? What if consumers are slow to change their preferences? What if they want to continue to use the kinds of fuels that they have been using? And they actually have a scenario for that in the SSPs. It's SSP3, and they call it, regional competition, rivalry, and that's very different. In that pathway, you don't get the same level of cooperation that might move the energy transition faster in some of the models. So this is something that's definitely worth thinking about, and I think is a very good area for researchers to do more work.
Oh, I see. Thank you. Yeah, Debajit is raising hand. We have 3 minutes left.
Very quickly, just take a minute. I think consumers of developed countries, developing and less developing countries, that's probably would have their own ways and means to think and then accept or not to accept it. It depends. For example, in India, I personally don't feel that there would be a large increase in price if we shift to renewables. Probably there are a lot of inefficiencies in the system which could be addressed and which would help in recovering more revenue for the distribution companies if we can address that instead of increasing the price. And secondly, if we can show some value to the consumers, how they are going to be benefited, I think they won't mind for an increase of some nominal increase. And we have seen that happening in the state of Gujarat, which is the Honorable Prime Minister's home state. When he had introduced reforms in electricity distribution sector in his state, I think everybody accepted it because they felt that they are also getting something in return. And it's not just the price increase that is happening. So I think we have to have a strategy for that, and depending on where we are implementing the program, this one. So that would be my take. Thank you.
Thank you very much. Unfortunately, we are running out of time. Even though we are given extra time for this closing session, I hope this conversation will continue in the society or in the association of the IAEE. And then I hope that we will actually see face to face, not virtually, in Tokyo next year. The organizer kindly prepared the video, promotion video, which we have prepared to advertise at Tokyo International. Hopefully the organizer can play that. And thank you very much everybody for being there. So for the last 4 days, hope to see you all in real very soon. Thank you.
As the co-chair of the next IAEE International Conference, I'll be delighted if you could join the conversation at our meeting that will take place in Tokyo, Japan during the summer 2022. I'll be pleased to welcome each of you personally. The Institute of Energy Economics Japan and the National Graduate Institute for Policy Studies are pleased to host the 43rd IAEE International Conference in Tokyo between the 31st of July to the 3rd of August 2022. There will be 3 main topics featured at the Tokyo meeting. The first one will highlight the different forms of zero carbon energy. Not only will we talk about the traditional ones such as renewable and nuclear, but we will also introduce and emphasize unconventional ones. The discussion on decarbonization will most probably be continued in Riyadh, Saudi Arabia during the IAEE International Conference to be held in 2023. The second most important component is that rapidly growing Asia and other emerging economies must meet their energy needs. Though the innovative and yet affordable decarbonization technology will help them meet their environmental aspirations. Third highlight is that the Tokyo meeting will invite and host prominent world-renowned and high-ranking stakeholders from industry, academia, and governments. We cannot be more excited and truly look forward to welcoming you in our beautiful city. In the meantime, we keep our fingers crossed that COVID-19 will end anytime soon. See you in Tokyo in 2022.
Well, I would like to thank all the people who are involved in organizing this wonderful first online conference. And I see Yannick is here, so I would like to invite Yannick to say a few words.
Thank you. Thank you very much, Hall, for attending. I will try to give you a couple of slides if it's possible, but if it's not a nightmare. I would like just to give a round of thanks to all the people that have come here, meaning nothing because we are online, but we have sponsors which have helped us, EDF, NG, Total Energy, Enedis, KAPSARC, BP, Terraga, and RTE, as well as academic partners. There are a lot of them, so I'm not going to get through all of them. by name, but you will find them in the programs, and you have seen them all around the sessions. I would like also to thank the professors that have helped me to build the program. They have been very helpful in the process, and they were coming from all the institutions in France that are working on energy economics. And it was quite a challenge to make them all together happy to work on such a great innovative project. And there is two more type of people I would like to thank and to conclude. The second is the technical people. You don't imagine how many people are working like crazy to make this online happen. They are very numerous, they are very talented, and you don't see them. So for the invisibles which are working, I love you guys and girls. And lastly, I have roughly 40 students that you have made cross in different sessions that I would like to thank, because if I don't do that, they will kill me at the end of the day, and I will not be capable to get back home. So I have to thank them very, very, very from the tip of my heart. Now it's done. I am totally exhausted, but very happy. And I would like to thank all the panelists for this very fascinating concluding sessions. This conference was beyond everything I know before, and I hope that in Tokyo we will have even better, different, and fantastic. So now it's time to have a beer or two and to get back to work, because it seems that both COVID and climate change have not been solved. So we still have a little bit of homework before rejoining in Japan. So I wish you the best and good luck for the next generation. Bye.